Hello, microeconomics class. I wanted to help you to understand what these graphs were all about. So I thought I might record me creating one. What we have here is an axis that's labeled with the dollar sign along the y-axis and quantity along the x-axis. The reason I put it as a dollar sign is because we're going to be talking about price with some of the graphs that we're going to draw on this, and cost when it's related to other ones. So that, and we're also going to use it to calculate profit. So we've got a combination of things. It's always dollar signs, but we're actually interlaying a number of different curves on there. I normally start with demand and marginal revenue, so let's do that. So if I wanted to draw the demand curve on this, we'd show that at high prices, the quantity demanded is low. These are low values down here at close to zero or something. Now we're not actually going to touch the axes because that would then anchor it to a particular value. What we want to show is a relationship. So I'm going to draw a downward sloping curve here. We'll make it a nice green line, make it a little bit thicker, and that right there is the demand curve. Now if we charged a high price, then we'd only sell a few units because people would find alternatives, that ways to spend that much money instead of buying our item. At the other extreme, if we charged an especially low price, we would sell many units in this market. This is a graph of the market demand for the product that we're selling, and it's a downward sloping relationship. This is hopefully a review for you. Now if I wanted to show the relationship between demand and I'll just label that with a big fat D for demand. And we're going to show now the relationship between marginal revenue demand, and we'll use a nice light blue line for that one. We're going to draw the marginal revenue curve is always twice the slope and inside of the demand curve. So it's going to be something like this. Now these numbers actually in the graphs themselves are a result of actual values in our market. I just wanted to show you a typical one so you have an idea of what their relationship are, so we can do some projections. Every business always wants to know how many they should be making and whether they're making the right number and so forth. So what we have here is a marginal revenue curve, which does in fact go into zero. The relationship between marginal revenue and demand is such that the marginal revenue curve is always inside the demand curve and twice the slope. So there's going to be these other graphs over here. Now this is going to be the ATC, and the we're going to label this one right here. This is going to be the marginal cost curve for that we're considering, and this right here is going to be the ATC for a particular. Now this is I'm gonna keep watching and you'll see what I'm leading up to. Now, and we're going to change the color so that we have another way of doing it. Here we have a different marginal cost curve and a different ATC. Now, in the case of the Twinkies and the Twinkie Miracle, what we had was a company that had very high costs and high revenue, but the revenue that they were bringing in was insufficient to cover their costs, and so they were losing money. Twinkie was a very profitable company for a long time, Hostess, but then they as you know, they folded when you read the article. So what we want to show is a relationship between demand and cost that shows that there was insufficient demand to cover the costs of the Twinkie under that one situation. We're going to choose to use this particular set of graphs right here, and it's always nice to see when I'm gonna just have to move this one over a little bit. All right, so we're going to use this set of marginal cost and average total cost, because what this shows is that the average total cost in low quantities was low, and the marginal cost in low quantities was also low. But as we increase the quantity amounts, the marginal cost increases. Why would we have a curve have such an increase in marginal cost as this, and that average total costs were basically matching up with marginal costs at great quantities? It must be that there was some operation that was high in variable costs, and that was the case with the Twinkie production. They had, even though they were mass producing, they were really doing some very labor intensive and small batches of deliveries and constant deliveries in small trucks, and many of them, and lots of labor, and they had lots and lots of variable costs in their business model, and that meant that their average total cost curves increased as they increased their output. They were not benefiting from economies of scale. They were actually at a point of diseconomies of scale. So in order to show what the relationship was, we have to show that the company was losing money. And the way that we show that is that the average total cost curve was above the demand curve. So the price that people were willing to pay for the Twinkie was less than the price or the cost of getting those Twinkies. If we tried to get 17 million Twinkies out into the marketplace, it would cost, the average of each Twinkie cost would be here, but the price that people were willing to pay for Twinkies was low. Now, there were people that were willing to pay more than that, but there weren't sufficient number of people to pay for that. If we wanted to sell 17 million Twinkies, we'd have to lower our price to a price that 17 million people or 17 million sales would tolerate. Now, at one time, perhaps, the demand curve was such that we had, I'm just going to show that what we have here is a possibility, and I'll change this into a light green line. This could have been the demand in the past. Under this scenario, we would have a demand which was high enough above the average total cost curve that you could make a profit. You could sell your Twinkie for this price, and it only cost you this much to make those Twinkies, get them to market, and so forth. And so the cost of the Twinkie was less than the price that people were willing to pay. But over the course of time, there were two things that happened. The demand for Twinkies dropped. They were still robust. There was still a lot of brand recognition, and people still loved the Twinkies, but there was a decrease in demand due to a lot of competition and health concerns and other things that are just changing diets and tastes and preferences and so forth. So there was a decrease in demand regarding that. And at the same time, you also had this average total cost curve was rising up due to an increase in variable costs that were driving it up. So you got to a point where you were not profitable as a company anymore. So they closed. They reached a shutdown point because their average total cost curves were higher than their demand curve everywhere. The death of the Twinkie meant that it laid the groundwork for its rebirth. And so what we'll show here is that when they automated and figured out a new way to do things, they put it more heavily with the fixed cost. They automated, they consolidated, and they focused much more on fixed costs as their production went. They extended the shelf life of the Twinkies. They had fewer visits. They changed their logistics, and so they reduced the variable costs related to their operation. They didn't change demand. Demand was always robust. That was one of the attractions of the brand to this rebirth, and that meant our marginal cost curve switched over to this. Now, in order to show that we're profitable, we have to put the average total cost curve below the demand curve. It doesn't have to be totally below the demand curve as I'm showing there. You can just put it somewhere below the demand curve. And what we would do is, let's say, notice, by the way, that the marginal cost curve in both of these always intersects the average total cost curve at the low point of the average total cost curve swing. That's a characteristic of the marginal cost curve, always does that. And so let's say that if, even after automation and so forth, if their average total cost curve were still too high, or they matched up to where it was before, or even only just decreased it by a little bit and so that it was insufficient, then you would find that the company still might decide not to open. But we know that they were profitable, and so what we're going to do is indicate something along this line. I think this will work very nicely. Okay, so at that point, what we have here is we find where, to find out how profitable they were, we're going to find where MR equals MC. And then we're going to go down to quantity and then up to the demand curve and then left to the price. And then we're going to compare to the ATC for profitability. So in the situation where we had the new situation, we've got an intersection point which is right there. Maybe I can focus that. This is the point where MR equals MC. The MC and the MR come together there, and that tells us when we bring our point straight down that we should be making this amount of quantity right here. That's the profit maximizing quantity to produce of Twinkies. To figure out what price we're going to charge, we say, well, if we're making, I don't know how many this is, let's say 8 million Twinkies or something, or 80 million Twinkies or 800 million Twinkies, whatever number of units that we're making, that our market tells us that the demanders in our market are willing to buy 8 million or 800 million, that this quantity, if we charge that price on the demand curve. That's the key part. Ignore the orange line, that's extraneous. If we're charging that on the demand curve up to the D, then that means that it corresponds with that price right over here. Try to make it a little more in line with that. And so what we're doing here is we found where the MR equals MC, went down to the Q, and then went up to the D. From there, then we go over to the left to the price at P, and that would be our profit maximizing price right there. That's our profit maximizing price. This here is our profit maximizing quantity to produce right there. And then if we wanted to see if there was a profit, we compare the cost, our average total cost of making that many. And that is found right here, where this vertical reference line that we created is right there. So that corresponds to this point right here. And that is our cost. So our price that we're going to charge is up here, but the cost of making each one, not only the manufacturing, packaging, advertising, all the overhead, all of the total costs, all the fixed and variable costs, all the required return on investment, the debt service, the salaries that we have to pay, advertising costs, delivery costs, the whatever kind of licensing agreements we had, all of the costs went into it, not just the flour and butter and sugar and so forth that went into it. And our average cost, our total cost divided by whatever many units this is. Let's say it cost us $400 million total to do what we're doing, and we made 800 million Twinkie packages, then that would mean our average cost is 50 cents. But we're selling them for $1.20. So if 50 cents is our average cost and we're selling them for $1.20, then we're making 70 cents on each one. And 70 cents on each one, or whatever the difference is between our average cost and our price, times the number of units we're making, let's say 800 million, would be our profit. So that nice little section right in there is our profit. Maybe I'll make it a nice dark green. That whole thing is our profit. Not that part. All right. Thanks. Hope you enjoyed that.